Hey guys, today we are going to be dealing with radical equations. Namely, we're going to be solving them. In other words, solving for x. What value of x would balance the equation? And so you've been probably solving equations for a while. These look like normal equations. There's an equals, there's a left-hand side, a right-hand side. The only issue is that there's a square root in the problem. So we'll go through a couple of examples, some more basic ones, and then we'll do two more that are a little more challenging. So for the first two here, notice that we have a square root of something equal to something. And the best way to do this is just to think of undoing. Like when you solve equations, typically you want to undo what's been done to build back to the answer. So here, notice that we have the square root symbol, which is our first order of business. And just think about it, the sort of undoing of square rooting is squaring. Okay, so if I square the left-hand side, then the square and the square root go, and all I'm left with is 1 minus x. Now, again, this is a balancing act, so what I do to one side, I have to do to the other. So if I square the left-hand side, I have to square the right-hand side. So the equals now becomes not equal to 6, but equal to 36. And then the rest is pretty straightforward, probably. So again, we continue to undo. So undoing adding 1 is subtracting 1. What I do to one side, I do to the other. And then that allows me to then see that negative x is equal to 35. And then if negative x is equal to 35, then I can think of that as negative 1x if I want to, and dividing both sides by the coefficient to isolate x. And so x here turns out to be negative 35. Now, it's really important with these kinds of equations to check them, because sometimes you get answers, we'll see in a little while, where you can get an answer and it seems right, but it actually doesn't work. So with this unit on equation solving, you do have to check it, which means you take this green answer and you put it back into the purple, is that the color purple, equation. So as a check, I'm just going to take negative 35 and I'm going to place it where the x is. I'm going to put it inside the x box. So that's going to be the square root of 1 minus 35, or plus 35. And if I add 1 and 35, I get 36. And in this case here, the square root of 36 is 6. And you can see that's exactly what the right-hand side is equal to. So it checks out, and you can call that a check. Your teacher will give you specific instructions on how to write your check. But for me, I just want to make sure that you check your answer to make sure it's not a bogus answer. Sometimes it's called an extraneous solution. And I'm just going to put a box around that because it's checked out and it's a good answer. Okay, so let's use that same idea for the next one. The only difference with this one is that I've got a 5 on the left-hand side, and then the radical, and then the 12. But if you think about it, I could just move the 5 over and isolate the radical. So that's going to sort of be a standard process. If my radical isn't isolated like it was in the first one, I'm going to do that first. So I'm going to just rewrite the square root of 2x minus 1. And then I can either think of moving the 5 over, or sometimes thinking of subtracting, but what you do to one side, you do to the other. Okay, so 12 minus 5 is 7. And now we're dealing with this equation, very similar to the one we did at the beginning. We're going to undo square rooting by squaring, so they sort of annihilate each other. What I do to one side, I have to do to the other. So the square and the square root make each other go away and disappear, so that all you have now is just the number or the expression under the radical. 7 squared is 49. And now it's a pretty easy equation, probably. We add 1 to both sides. That gives me 2x equals, notice those are going to cancel away, and that's going to give me a 50. And then I want to, again, undo multiplying by 2, so I divide by 2. What I do to one side, I have to do to the other. So you can see the answer here is 25, allegedly. Now you have to check it. We're going to do a little check here. Don't make a big deal out of it. Just don't get caught by a bad answer. So you take 25 and you put it inside the x box. So I'm just going to go to the blue. Always go back to the original equation, the blue equation. So 5 plus the square root. You can do some of this in your head if you want to. 25 in the x box times 2 is 50. And then 50 minus 1 is 49. And the square root of 49 is 7. And 5 plus 7 is 12. And you can see it checks out. The other side is 12. I want to make sure that this number is going to balance the original blue equation. So it checked out, so I'm going to accept that as my answer. All right, so let's take a look at this next one that has a square root in it, but also has another variable. So we have to make some choices before we just start squaring both sides. And the general rule will be to isolate the radical, get the radical all by itself, okay? So what I'm going to choose to do here is think of subtracting n from both sides. And that's going to get the radical isolated. So negative square root 5 minus n equals negative 7 minus n. Now you're noticing here that everything is negative. And that's a really good time to maybe multiply through by negative 1 on both sides. And the magic there is that everything changes sign. And in this case, everything goes positive. Okay, that's good, because now we have this radical isolated. It's equal not just to a number, but and with an n in it as well. So it plays out the same. So what I'm going to do is I'm going to square this side, because I want to get rid of the radical. And I'm going to square this side, because I have to balance the equation. So this is going to release the radical. So that's going to give me a 5 minus n equals. Now on this side, be really careful. That's actually 7 plus n times 7 plus n. So it's easy to say that's 49 plus n squared. It's not. You have to expand it out. And then you FOIL it first, outside, inside, last. And on the right-hand side, 7 times 7 is 49. And 7 times n is 7n, positive 7n. And n times 7 is again 7n. And n times n is n squared. On this side, I don't do anything. I just leave it as is. And you can see this has evolved into a square root, a quadratic. So in quadratics, the idea is to get everything to one side with 0 only on the other. So what I'm going to do is I'm going to make this side 0, which means that these two terms have to get booted. And the only rule that you have to follow is that the signs, the terms change sign. So a positive 5 over here becomes a negative 5 over there. A negative n here becomes a positive n over there. Okay, I'm going to lead with my n squared, so n squared. And then a 7n plus a 7n is a 14. So plus 14n. Now, the negative n, when it gets brought over, it's going to become positive n, or positive 1n. You can put the 1 or not, it doesn't matter. And there's a 49, so plus 49. And the 5 gets booted over, becomes negative 5. All right? Okay, and then again, I can collect those terms. So you can see that these are like terms, and these are like terms. So 0 equals n squared. And 14 plus 1 is 15. 15n. And 49 minus 5 is positive 44. All right, at this stage, you have choices when you want to solve a quadratic. Notice the problem started out as a square root problem, a radical equation, and it's evolved into a squaring equation or a quadratic equation. There's really two ways to do it, formula or factorization. I'm going to use factorization. And the idea with factorization is you want two numbers, so two numbers, that multiply to give the last number, and also at the same time add to give the middle number. And you can write them out if you want to, but eventually you'll realize that 4 and 11 multiply to give 44, but they also add to give 15. So those are my numbers that I'm going to use. And so 0 equals bracket, 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 bracket. I'm factorizing it, just like I did in grade 10. So I'm going to write n and n. And then I just drop the numbers in, plus 4 and plus 11. Now what we know is that if you have two numbers being times together, in this case n plus 4 times n plus 11, that one of those has to be 0 because they're multiplying to give 0. So either n plus 4 is equal to 0 or n plus 11 equals 0. And if n plus 4 is equal to 0, then I can subtract 4 from both sides, and n is going to be equal to negative 4. This one here, if I subtract 11 from both sides, n is equal to negative 11. Now I have to check my answers. This is really important with radicals because very often the answers are what we call extraneous and they just don't balance the original equation. So let's check them one at a time. So let's check the negative 4. If I just put a negative 4 here where the n is, keep track of it, and then I put a negative 4 here, well, I can do a bit of arithmetic in my head. 5 minus 4 is 9, and the square root of 9 is 3. So this whole thing becomes 3. And so negative 4 minus 3 is negative 7, and that's good. So we accept the answer. So I'm just making sure that it balances the equation. Let's try negative 11. So if I put negative 11 here, I'm going to put that to the side, say that's negative 11. And same as here, this is negative 11. So let's work inside the radical first. So 5 minus 11 is 5 plus 11, and 5 plus 11 is 16. And the square root of 16 is actually 4. So let's see if this works. So negative 11 minus 4 actually is not negative 7. It's actually negative 15. So unfortunately, since this answer did not balance the original equation, we reject it. Okay? And that becomes known as an extraneous solution. Okay? So this question only has one answer. All right, so final example of the video where we have an equation that has two radicals in it. So radical 1, radical 2. So far we've been using the idea of isolating the radical. In this case, if you have two, what do? Well, you still isolate a radical. And it really doesn't matter which one. I typically go for the one that I like the least. So this one here looks a little more complex, so I'm going to isolate that one. I've got a positive 5 here, and that's going to come over to the other side. And so in other words, I'm thinking of subtracting 5 from both sides. Okay? And then that allows me to isolate that radical. So equals the square root 5x plus 4. And over here, the 7 minus 5 gives me a 2. And then I've got a positive root 3x. Okay? So I've got this thing isolated, and now I do what I did previously. I square it. Okay, so squaring and square rooting are inverse operations. They undo each other, which allows me to get 5x plus 4 all by itself. Over here, I have to also square because I'm balancing the equation. Don't forget what that is. That means 2 plus root 3x times 2 plus root 3x. So this needs to be expanded out using the distributive property or FOIL first, outside, inside, last. So 2 times 2 is 4. And 2 times root 3x is positive 2 root 3x. And then 2 times root 3x is again positive 2 root 3x. And then root 3x times root 3x is positive 3x. So we've seen that pattern before, where you have a square root multiplied by another square root, and the numbers under are exactly the same. The answer is just the number under the radical. It's kind of nice. Equals 5x plus 4. All right, I still have a radical. So what I'm going to do is I'm going to collect like terms, isolate this radical, and do the same thing. So it's like you have to isolate the radical 2 times and square. So I'm going to combine my root 3x's. So these two terms are like. So that gives me 4 root 3x. And then I'm just going to say equals. I'm going to send the 3x over to the other side. So I'm going to subtract 3x, and that's going to give me 2x on the right-hand side. Also, look at, I've got a 4 here and a 4 here. So if I subtract 4 from both sides, it vanishes, it goes away. And so this question simply boils down to this kind of simplified question where I have a radical, I have a coefficient, and I want to get rid of the radical. How do you get rid of a radical? You square. Even with the coefficient, I can still do that. So I'm going to square the whole thing. What I do to one side, I got to do to the other. And if I square this, that's going to be what? 4 root 3x times 4 root 3x equals, well, that's 2x times 2x. So 2 times 2 is 4, and x times x is x squared. Okay, we're doing good. Now I'm going to times these together. So that's going to be 4 times 4, which is 16. And then root 3x, this is where the magic occurs, times root 3x is 3x. That's it. Remember, the idea is the numbers are the same under the radical. So when you times them together with square roots, you just get the number under the radical. You get rid of the radical. Equals 4x squared. Okay, well this is starting to look like a quadratic because 16 times 3 is 48. 48x equals 4x squared. And now the goal is to solve a quadratic. Remember, there's 2 ways to do it. You can use the quadratic formula or you can use factorization. I'm going to choose to use factorization, but again, when you're doing these quadratics, it's important that one side be equal to 0. So I want this side to be 0. It doesn't matter which side, just choose your side. The 4x squared is already over on the other side. I'm going to move this over to the other side, which is going to change its sign to negative 48x. And now it's about factorization. So I'm going to take out a greatest common factor here. So that's going to give me 0 equals the GCF, the greatest common factor is 4x. And I'm going to divide it out. So 4x squared divided by 4x is x, minus 48x divided by 4x is 12. Okay. So here we are again. So there's a times b equals 0. So either a is equal to 0 or b is equal to 0. Do you see? When you're multiplying two numbers together and they equal 0, one of them has to be 0. So either 4x is equal to 0 or x minus 12 is equal to 0. Okay, well if 4x is equal to 0, that means x is equal to 0. Okay, you're just dividing both sides by 4. And if x minus 12 is equal to 0, then that means that x equals 12. Okay, so those are our 2 answers, but we have to check them. Don't forget, they have to balance the original equation. So I'm just going to make sure that I'm using the correct equation here. And I'm just going to try the 0 first. The 0 is easy. So if I put a 0 here, and a 0 here. 3 times 0 is 0. The square root of 0 is 0. So this side just becomes 7. Take it to the other side. 5 times 0 is 0. 0 plus 4 is 4. The square root of 4 is 2. And 2 plus 5 is also 7. So we accept this as an answer. Let's try 12. Again, doing it in your head is okay. If you put a 12 here, well, 3 times 12 is 36. The square root of 36 is 6. 6 plus 7 is 13. Okay, I need a 13 on this side too. Take the 12, put it here. Don't think of 0. 5 times 12 is 60. 60 plus 4 is 64. The square root of 64 is 8. And 8 plus 5 is 13. So 12 makes both sides equal to 13. So we accept that answer as well. So both answers check out this time. Okay, so in some cases you might get no answers, sometimes you get one answer, sometimes you get 2 answers. It just depends on the original question. Don't forget to check your answers. All right, if this video helped, please slap a like on it, and don't forget to subscribe for many more videos to come. And if this was helpful for you, share it with someone who might benefit. Thank you.